All right, so let's talk about your lab report for the freezing point depression. It's due the next week you come into lab. For page 1, I want the lab report form. You will get that from the chemistry website, same place where you got your procedure. This time though, you'll print your lab report form and place your data in it. Second page on are your graphs. You'll have a total of 6 graphs. They can be on separate pages or you can have them on the same page. I would suggest not more than 2 to 3 per page because at that point then it's going to be difficult to discern what you need from it. Remember a graph, the axes should be labeled. So for example for this one it's temperature in degrees Celsius. You always want units versus time in seconds, and you always want a title. I will look for those items and I will grade it based on that. Then in the next page, whatever it is, depending on the number of pages you use for all of the graphs, make sure you graph everything, is that you're gonna then have calculations. I want all of the calculations. I want to see all of the calculations. Please make sure that these are legible and easy to follow so that I can grade it easily. If I can't find it or read it, I can't grade it. So you'll return it and I'll have to return it without a grade for that. So make sure that you do all the calculations and they're easy to read. And then the last page, I just need a carbon copy of the data that you collected. So that way, if I have any questions about the graphs, I'll have the data there with me. That's what I want for the lab report in that order. So that way I can quickly access it. And now let's talk about what you're going to be doing to generate the data. Now remember, for this one, our goal is to find the molar mass of your unknown. Now molar mass is in what units? Exactly, it's in grams per mole. Now you already have the mass that you used. In the first trial, so the first trial with the solute. Now remember, you had solvent before that, but we want to know what the unknown is, and in this case, it's one of the solutes. The solute dissolves in the solvent. So the first trial, so this would essentially be 3 and 4 of your data, you added roughly 1.5 grams. So for that one, it's going to be 1.5 grams. For the second set of trials, so the second trial with your solid. Now again, this is the second set, so I might put in second set and first set up here. The trial with the solid, you added another 1.5 grams. So the total here would be roughly 3 grams. Now again, you mass that out. So be careful because your molar mass will vary. So on the first time that you add the solid, you only added 1.5 grams. So you put that 1.5 there, calculate the moles. On the second set of trials, so this would be trials 5 and 6 in terms of your data, that's going to end up being 3 grams here. Make sure that you watch that or you're going to get very, very different molar masses. So 1.5 for the solid, those first 3 and 4, and 3 grams for that second set, 5 and 6. So our goal is to find the molar mass, and we're going to get there. But to do that, we need those graphs. So the first part, once you generate the graphs, you'll have data points, and they're not necessarily going to be exactly on that line. You're going to do best fit lines for these. You'll do one where you see the slope going down and one where it levels off. You can do this in Excel. I do want this generated in Excel as a plot, a scatter plot. If you don't know how to do the line here or here as doing 2 lines, that's okay. Go ahead and print it off with the scatter plot, and then you can go ahead and you can take a ruler, I will accept this, and actually add the lines. So you can add those lines in. Where they intersect, so you'll come across, that is either going to be your TF, so this TF means you've got solvent in solution, or if it's your first couple of trials with just solvent only, you're going to be looking at your T naught F. So it's going to depend on what's in that solution, but that's how you will get that data, is directly from the graph. So wherever they cross over, then you're going to end up coming across and looking at that. Then in the next part, when you look here, you're going to have TF minus TF naught. Now remember, comes from the graph. So graph here with solute and solvent. Here you've got your graph and it is solvent only. So that comes from your graph. That's why you need those graphs. In your lab report information, the procedure, it tells you it's a non-volatile, non-dissociating solute. So that tells you that I is 1. It also tells you that Kf of the paradichlorobenzene is 7.1 degrees Celsius per mole. And then in the last step, you have moles of your solute. And again, that's what you're looking for. And you've got kilograms of solvent. And in this particular case, you used about 12.5 to 13. I'll say that I used 12.50. So we've got to correct that, or at least convert it rather, to 0.01250 kilograms. And then we solve it, lo and behold, and we get moles of your solute, and we can plug it in right there to get then your grams per mole. So again, TF and TF naught come from the graphs that you make. You'll have 3 sets of them. Then you come over here, you plug in the TF and TF naught, the averages of those, plug in these values to get your moles of solute, and then it'll get you to your molar mass of your unknown. Biggest thing to remember, and I know I keep reiterating, is that first set of solvent trials, it was just 1.5 here, and you'll have a number of moles. The second set of trials, which are 5 and 6 data sets, you're going to use the 3 grams, you'll get a different number of moles there. All right, that's your lab report.